Are you recording this?
Yeah, just started. Back in geometry.
You don't have your circle on.
7.
What don't I have on? Oh,
You're welcome.
thank you.
It's like 7-2.
It will be when we start writing. We're not writing yet. Okay, this is in your book. What this is an explanation of if you have the parts angle, side, side. We didn't have that back in geometry. We had angle, side, angle, 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 side, 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 side. Because when they gave you those three parts, they would always build a unique triangle. If I give you parts in the order angle, side, side, three things can happen. You may not make a triangle, you might make one triangle, or you might be able to make two different triangles with those same three parts. That's why it's not a unique situation. It's called the ambiguous case. So if the given angle is acute, that's this angle here they're showing you. And then you've got a side B after it and then a side A. Well, if that side A isn't long enough, you don't even create a triangle at all. So that could happen with angle, side, side. The next one shows you an angle, a B, and an A side that's just long enough, you will make a nice right triangle. Okay?
Stop breathing so heavy.
Quiet, please.
I'm stressed.
Here, angle, side B, and then a little bit longer side A, you create this nice obtuse triangle. And the difference here is that A is greater than B. And then the last one, here it is. An acute angle, this side, and side A. See this triangle here? I can take that side A and swing it out, and I create a second triangle with those same three parts, a great big obtuse one this way.
It's freaking magic.
So, with the same three parts, it's potentially possible, if that given angle is acute, to make two different triangles. And that's where your side A, the length of it, is smaller than B but bigger than the height. Not that that matters.
What's the swing thing?
That's showing you the two triangles.
Okay.
No, but you said you could swing B.
Swing A. A swings out. So you can make this triangle here,
That was the original triangle made, right?
or with the same three parts, you can make this big triangle here. So with given three parts, a small angle in these two sides, it's potentially possible to make two different, completely different triangles. And I'll tell you how. If the given angle is obtuse, only two things happen. You either don't get a triangle because side A is not long enough, or you can get one triangle if side A is long enough. So, when it's angle, side, side, you're going to have to write it down. You're going to have to remember, boy, if the angle's acute, I might have two triangles and have to check for it. So I'll show you how all that works now. So, here we go. All you have to do is remember to check for the second triangle. And I will show you how all that works right now. Now we write. So it's still going to be using law of sines today.
Turtle next galaxy. 7-2 day 1.
7 to day 1. So we're going right into solving the triangle.
No, we don't miss you. No, I miss you too, Kate. You go. Did you hear that? 5th hour? 4th hour? Frickin' Miss Katie Maloney. Oh, okay. Really quickly. Shut up before I punch you in the face.
Little c. Little c.
I really played for this. Did I guess right?
Okay. So there's the three parts.
So that big C.
That's little. It's inches, so it's got to be little c.
We gotta make them smaller.
So, draw the triangle. I have no idea what three parts those are without the picture. So B is 54. C, little c is 28. Make sure you're labeling in the right spot, and little b is 23. I do. I don't try to make them look to scale. It doesn't matter. You just need the positioning so that you can get the proportions right. Okay, do you recognize this as angle side side or side side angle, first of all?
Yeah. Angle side side.
Okay, recognize it as angle side side.
Yeah.
because of the positioning. You've got an angle and then the next two sides. What else would you think it could be? And I'll tell you why it's not that.
Side to side angle.
That's fine.
Saw.
SSA is same thing.
Huh? You didn't reply fast enough.
Do you want it to be something else?
Sorry.
Okay. So, recognize it as angle side side or side side angle, and then right away you got to say, oh, she showed me that picture. There might be, because this is acute, there's the potential for two triangles here. So, second triangle, maybe. That's what you got to know right off the bat, that I need to check for the, and I will show you how to check for the second triangle as we work through this.
Okay, so we don't know if it's
You don't know.
angle.
This could be, what?
We don't know if it's angle.
I don't know if there's two triangles here, one triangle, or no triangle.
So I'm talking about the angle
Or side-side angle. Yes, you should know either one of these.
No,
Okay.
it's the same thing.
It's the same thing, that's why I got the or. It's just backwards.
Oh, model answer.
Okay, so there's a possibility for a second triangle, and I will show you how you work it out. So what you see is a side with an angle, so you can set up proportions, just like we have been. So we're going to do that. So 23 over the sine of 54. Equals, what's my other proportion going to be?
28 over the sine of
Over the sine of C.
C. Do we need to be in degree mode?
Absolutely. So now we'll do cross products. I'm going to do the steps in here. Once you get comfortable, go ahead and skip them on the writing them out. But it would be 28 times sine of 54 equals 23 times the sine of C. Then I'll divide by 23. That will leave me with sine of C.
Do you have your calculator charger? Like that. I don't know, it's not replace the battery. I don't know. No, it's, you charge it. You charge it. You look at that.
So 28 times sine of 54 divided by 23. I got 0.9849.
I can't find mine.
Now what do I do to both sides of this equation to figure out what angle C is?
Then negative 1.
Inverse sine. So if I know the sine ratio to get the angle, I'll do the inverse sine. So inverse sine, I'll get C equals, so I'll do inverse sine of that answer. I got an 80-degree angle.
I don't remember using the inverse.
We didn't before. When you have angle side side, the only thing you can find is a missing angle, so you have to use that inverse. That's why it's in a whole new section.
Ms. Schwartz, do you have a calculator charger?
No, I don't. I have old ones. Okay, right now is when you say, boy, if that's an angle in one of the triangles, I must be able to find a second angle right now. So, what you're going to do is make a little table to keep track of everything. Triangle 1 and triangle 2. Because if there's two triangles, there's going to be two different sets of values. In one of the triangles, the first one, angle C is going to be 80 degrees. And this is where you check, well, for the second triangle. C in the second triangle. And you're just always going to do this, and I can try to explain why, but it might not make sense to you. Because we wanted the sine ratio here to come out 0.9849. There's actually two angles that have that ratio. The other angle that has the sine ratio is the supplement to this. How do I do the supplement to 80? What do I got to do any supplement? Subtract it from 180. So whatever you find for your first angle, you're always going to subtract from 180 to get the second angle. So what could my second angle C be? 100 degrees. So right now it's looking pretty good for two triangles.
What would be a red flag?
You would have no red flag yet. The red flag's going to come up right now in the what we find next. Okay, so this angle C could be 80, or it could be 100. I should say and it could be 100. Okay, so what would you find next on this triangle? Angle A would be the only thing you could find next, because I don't know little a to set up, I'd have two unknowns, but I can find A next, because I know these two angles. So in triangle 1, how would I figure out angle A? If I know 54 plus 80, the two blue angles added together, and then this one. So 180 minus the 54 plus 80. What would I get for angle A? 26?
46.
46. Okay. Second triangle. What are my two angles in the second triangle that I know?
Looking at about 30.
Not what do the two angles I know. What are they? 54 and 100. The 54 doesn't change. That was given to me. But this angle C can switch to 100 in the second triangle. So 180 minus 54 plus 100. Is there anything left? 154. 180 minus 154. 26 degrees. No problems. There's no red flags here. You're going to see when a red flag happens. So we do have two triangles.
Yay.
Okay, so my angle A could be a 46 degree angle, and it's going to be a 26 degree angle. So I've got to find, what's left to find? Little a in both triangles. So I'll go back to my proportions, my law of sines. Okay, are you ready? Okay, this is one where I'm going to work to the right and to the left, so if you want to space accordingly. What?
Are you crazy?
No? Just trying to save you some time here on this one. You don't have to. You can set it up as two separate ones. Okay, what's the proportion that's the same for both triangles that I can use? Where's the angle in the side that's the same on both of those triangles? The B's are the same for both triangles. So I'm going to use that. So 23, work in the middle, over the sine of 54 equals little a over the sine of 46 would be fine. And if I set up the other one, can I set up the other one right now? Or let's just solve this one. Okay. So multiply, divide on your calculator. It's all calculator work at this point. You've been doing it for 2 days. You should be good at it. So I know, 23 times the sine of 54.
What did you just say?
Oh, 46 divided by, what's under there? Sine of 54. Oh, that's got a big glare. I can't get it just right. Sine of 54. Little a is 20 point, let's see how many sig figs. So 20 with 2 sig figs. So that was with the 46 degree angle, so I'm going to put that in its right spot. So when A was 46, we got a little a of 20. Now, because I still am going to use this 23 over sine of 54, I'm going to work to the left, like I said. I'm going to forget about this one. What's my little a going to be divided by in this second triangle? The sine of 26. And I do the cross products here. So multiply here, divide here. Two sig figs, 12. And I'm going to put it in my little a equals 12. Okay, so we did have a 2 triangle one. Those are the long ones. Try another. Oh yeah.
How many are we doing?
Wait and see.
So how do we decide? if it's
You'll see.
triangle?
Wait till I'm all done. Then your questions will be answered. A is 40 degrees. Little a is 35. Little b is 30. Same as last, oh, not quite as much as the last one. So a is a 40. Little a is a 35. And little b is a 30. So what position are these 3 parts in? Angle, side, side. So there is a possible second triangle. So all we do is we start setting up our law of sines proportions and see what happens. We've got to remember to check for the second triangle right off the bat after we find our first part. So maybe I'll do my little triangle 1, triangle 2. What are my options if the angle's acute? I could have no triangle, 1 triangle, or 2 triangles. Okay, here we go. What can I set up? Where's my proportion? The A. So 35 over sine 40 equals 30 over sine B. Do the cross products. I'm going to write it out for the notes purposes only today. So 30 is going to get multiplied by sine of 40. 35 is going to get multiplied by sine B. Divide by 35. Times sine 40 divide by 35 and then inverse sine I got an error. Anybody else? Did you get an answer?
Yeah, 30.
What did I do wrong? Oh, guess that's how. Inverse sine. Oh, shoot. Ugh. Shoot. What is it? Inverse sine. What was the decimal?
0.5509.
Okay, that's good.
0808.
So did you get about 33 degrees then?
Yeah.
All right. Okay. So angle B would be 33 degrees. So right away, I know there's a second triangle, so I should be able to find the other angle B. What do I have to do to get the other angle B?
You know there's a second triangle
Because of angle side side. This is what tells you right off the bat to check. It's the only time you've got to check. So you have to look at what parts are given first.
Well, if it is,
Yes?
there will always be a second triangle?
No, there may be a second triangle.
That's why you have to check.
Yes.
How do you know there's not a second triangle?
You don't yet, because we haven't done everything yet. Right now. Why is this not turning out right? So we would go, how do I get the second angle? 180 minus 33. So 180 minus 33 is what? Oh, maybe it's, what is it?
147.
147. Oh yeah, it's coming up right now. So the angle B could be 33 degrees, or it could be 147 degrees. This is where the second triangle will fall apart, if it's going to fall apart. Because what are we going to find next?
That 40 plus 147 equals greater than 180, because that's impossible.
What are you going to find next?
I was right.
Angle C. Angle C is 180 minus the two that I know. What two angles do I know in my first triangle? 40 and 33. Yep. So if I do, that's C, that's
107.
180 minus 73. 107. In the second triangle,
What a guess then. Oh wait,
what's going to happen in the second triangle? 180 minus, what are the two angles I know in the second triangle?
147 and 40.
40 and the 147.
You know, 147.
What happens when I add 40 and 147?
Greater than 180.
So my angle would be a negative 7 degrees. What's that telling me? There's not a second triangle. This is where it falls apart. That should be a big red flag that the angle's coming up negative. So the second triangle doesn't exist. There's one triangle. Okay, so we only have to find one more part then. This 147 doesn't work for us. We just got to find little c with a proportion. So that I'll stick with the 35 and the 40. I could use the 30 and the 33. That would be fine too. Doesn't matter. But I'll stick with the 35 and the 40. And it would be little c over the sign of what?
107.
107. And then it's just calculator work. $52. Anybody else? 52. Okay, one last one, and it's very short. Why would it be short?
Because no triangle.
Because it's not going to be a triangle. Oh, it's going to be angle side side, but it's going to come out to be no triangle. And you'll see what happens when you just go in and why no triangle shows up right off the bat. I can fit it right here.
How much?
I can fit it on that little bit of paper there. Angle B is 100 degrees. Little b is 60. And little a is 82. Label your three parts. Now recognize the position of the three parts. What position are they in? Angle, side, side again. Okay, that's a red flag that says, ooh, there might be a second triangle. Triangle 1, triangle 2. Set up your table right off the bat so you don't forget. Even though I know this one's going to come out no triangle, you'll see what happens. Okay, so we set up our proportions, 60 over the sine of 100. Equals 82 over the sine of A. What was the situation with 100? What was obtuse? There was only two situations. You either got one triangle or you got no triangle. Oh yeah, this really wouldn't, but that's okay. Let's just pretend that every time we're going to check for a second triangle, just in case. But truly, yeah, with obtuse, there's only two cases. One triangle or no triangle. But that's okay. So we'll cross product this thing. So 82 times the sine of 100 divide by 60.
Error.
I didn't get an error yet. When am I going to get an error? Yeah, because this is giving me a sine ratio over 1. So that means like the opposite divided by, or the hypotenuse divided by the whatever is coming out wrong here. So inverse sine that, this is where my error shows up. So that's telling me no triangle. And that can happen if the angle starts out acute too. This is where it'll fall apart right away on the first step. When you try to find the first angle, you'll get an error when you do your inverse sine. So, I gave you 4 problems today for homework. There's going to be one of each and a double of something. 4 angle side side problems today. Page 295. Yep. 21, 23, 25, and 27.